Hello, Flat Earth researchers, debaters, and debunkers. If you are a defender of the globe arguing with a flat earther and desperately trying to explain how the angled view to the horizon is proof that we are on a spinning ball Earth, then you have got it all wrong. You are approaching it from the wrong angle. You are not seeing what the flat earther is seeing and is trying his best to explain to you. Of course, the maths appears to fit for the geometry of a globe said to be the size of the Earth we are upon. So these mathematical formula, which arrive at very precise results, seem to be infallible. On paper, with a global coordinate system, everything seems to perfectly match the idea that we are on a sphere. So you're thinking, what's the problem? Why can't they understand the maths that proves the globe? What's wrong? Well, what's wrong, literally in the eyes of the flat earther, is the understanding that we see the world in a particular way that has everything to do with the eyes we use to see it. It's a case of really seeing what the eye sees and how it sees, and how the surface always rises up to eye level. Okay, you can dispute the idea of eye level, but there is also a band of convergence below eye level. But essentially, regardless of the increments of angles that you can get between an apparent horizon and eye level, regardless of all that, the surface rises up to fill most of the bottom half of our field of view when we are looking directly ahead. This is a phenomenon that cannot be ignored. This is the way we see the world, whether it's flat or round. So flat earthers see that the prism-like vision with which we observe our physical reality is a consequence of what's happening inside the eyes and how our eyes translate the environment, and how that has been reverse engineered, or that aspect has been taken and calculated. The limit of our vision, the optical effects, the optics, the way the eyes work, has been translated into physical curvature on a geometric model. So flat earthers understand that to look at the geometric spherical spinning ball Earth model, you have to use geometry and you have to refer to geometry. But to really see and understand the flat Earth model or concept, you don't use geometry that proves the globe. You use the understanding of how our eyes interpret the surroundings, whatever shape they are. Perspective. So what is perspective, and how has it been translated into geographical curvature? So we know just by looking around us at any height that the surface always rises up pretty much to the halfway level of our vision. It fills up the entire bottom half of our vision. This is simply the way the eyes work. They see a flat surface, but that flat surface rises up to meet the sky, possibly with a band of convergence in the middle, depending on all sorts of things. In the environment, the light, whatever, temperature, air density. So there is the understanding that optically there is a limit to how far we can see, and that limit gets shorter or becomes longer as we go lower to the ground or rise up above the ground. It is simply understanding that everything we see is because light is being reflected off those objects into our eyes at a particular angle. And if you understand or know about angles of incidence for reflections, we understand that there is a limit when an angle becomes too obtuse to reflect anything. Then of course we will not see that reflection. So when the sunlight is on the sea or on the surface of the earth, it is reflecting light, and that light is making a path to our eyes. But everything on the surface makes a line towards our eyes and converges at eye level and fills up the bottom half of our vision, and then the sky fills up the top half of our vision. And of course the sky has a lot more depth to it. There is a lot less being reflected from the sky into the top half of our eyes, our vision, our field of view. But of course there is a lot of reflected light coming off the surface. And so the closer we get to the ground, the closer the horizon becomes, because the angles of incidence of the reflected light become too obtuse, and everything becomes blurred and confused and condensed at a much shorter visible distance. So let's take a look at this from a pilot's perspective, or an external frame of reference of a pilot's perspective. And we have a red line representing the pilot's eye level and his horizon, with the surface coming up to that eye level. So this is the major question. What makes the surface appear to rise up to the pilot's eye level even though he is off the ground? Well, it's the angles of the reflected light coming off the surface into the pilot's eyes, represented here by these faded blue arrows directing reflected light up to the pilot. And this reflected light from the surface will never go above eye level. It will always come and fill the bottom half of the pilot's vision. So from the pilot's perspective, it's like flying level with the rim of a cocktail glass, and the flat surface beneath is as if it is painted onto the inside of this cocktail glass. So the pilot will never see anything on the surface tilting away. The surface appears to be perfectly flat, yet this angle of light reflected from the surface to the eyes dictates this kind of cocktail glass angle of the surface as it rises up to meet the pilot's eye level, creating the horizon for the pilot at that particular height, indicated by the red crosses there. So now we can see that as the pilot goes down above the flat surface, the angle of incidence of reflection from the surface makes the horizon come closer and closer as they go down. And then as the pilot rises up, the horizon expands, remaining at eye level, but just allows the pilot to see further and further across the flat plane. So the higher we go, the less condensed our view becomes across the flat surface, and therefore allows us to see further, because the lower we go, the more things closer to us are blocking off the surface that is farther away from us. The light reflected from the surface in the distance simply cannot reach our eyes. So this is really the only way we can explain how a pilot can be flying level at, say, 40,000 feet and still see the surface appear to take up pretty much most of the lower half of their vision. And of course, the higher you go, the more less defined the horizon tends to be, because you've got so much more reflected light of many, many colors coming off the surface and blending into white light. Thank you very much.